Maybe close up and not close up.
You can like zoom in and zoom out.
When Greg's talking and Tupa will be talking, you want me to focus on there?
Online to see Brendan? Mm-hmm. Okay, thank you.
It won't be online today though.
Oh, so we before the midterm.
Before the midterm.
Okay.
That's what I said.
I think we just so we don't have two notes. Do you want this back?
Where is it?
Read it.
No, you're gonna be here. In charge of filming?
Huh?
You're in charge of this? Did you do it last time?
Cheated.
We both are. Yes. We both in class.
I was not scoring.
Okay. Nice.
When he's doing problems, not the answers, just the problem. As long as you can get like the numbers and everything. As long as you can get like the numbers. Just a problem.
When you're supposed to be here?
In a couple of minutes.
Yeah. Well, enjoy.
projector going on. Maybe that is some help. It's from here. No, it goes from here. That will work. Feel it? Take the whole wheel, huh? It seems like quite a few people are not morning people. Takes the whole wheel.
Still do online. Yeah, but not today.
Not yet.
You want smart send me a link to a link
Yes, so many times we've heard your teacher tell me about the focus of the concentration is on the grades. And that is a great mistake that all of us make, parents, teachers, students. We're focusing on something that it is not the most important thing, that we might have the degree and the grades, and we might find ourselves in a very big depression after we graduate. Jobs can be taken away any moment. And if we think we are just chemists or physicists or historians or this or that, our fall is 100% sure. And therefore, the most important thing, as your teacher tried to tell you so many times, is to build up a confidence that no matter what the circumstances will be, you will be able to go through. And it doesn't matter how many times your teacher will tell you that. Teacher thinks that it's not as powerful as it is to hear it from one of your schoolmates. So there is perhaps dozens of examples of students that they saw the reality of this understanding, and they made the leap within the 4 years of college to actually follow the deepest part of their heart, to go and do something they truly feel like they just love. And one of them is Gregory today, Del Rosario, Greg, who was one of my students a few years ago. And he's going to tell you in a few minutes his story that I think you should try to remember.
Hello, can everyone hear me? So, thank you, Dr. Toupadakis. I really appreciate the introduction. Now, look at all of you here on a Sunday morning. I can tell you guys are the good students because who else would sacrifice to be here on a Sunday at 10 a.m.? But I also know you're here for chemistry, so I'm going to try and keep this brief. And so my name is Gregory Del Rosario. I'm a third-year biomedical engineer. And if you would give me a moment of your time, I'd like to speak with you about my transition from computer science to biomedical engineering. 2 years ago, I was in Dr. Toupadakis' Chemistry 2A class, as well as his seminar, winter quarter 2011. I was in your shoes. I was a freshman, general chemistry, eyes wide open, but back then I was a declared computer science major. I thought for sure that was going to be the path I was going to take. I had already had experience in it. I was pretty good at it, and everyone always told me, Greg, you're one of the best computer scientists to know. You're the guy that's good with computers. To put this in perspective, by the end of my freshman year, I had already had research, ECS 99. I had secured a summer internship at a defense contractor that paid quite handsomely. But when I finally got to that internship, they put me into a cubicle, sat me in front of a computer. I programmed 8 hours a day, 40 hours a week. That was great for the first couple weeks, first month, and then I found myself getting tired. I found myself worn. I found myself incapable of concentrating. I didn't even want to go to work anymore. The fact that I was getting $20 an hour, that didn't even matter. Because you know what? I wasn't satisfied. I always had an innate sense to want to help people. And I found myself, even though I was good at computers, my heart wasn't there. I wanted to do something that truly helped people. And so, in my sophomore year, thanks to Dr. Toupadakis, in fact, during my internship, I heard him, Greek voice and all, telling me, you have to succeed. You have to do what you love. That's when you're going to succeed. Even though you may be good at something, if that's not what you love, you're not going to be a true success. And in my sophomore year, I made one of the toughest decisions I've had to make in my academic career. I switched out of computer science, which was almost a guaranteed 3 years out of here, to biomedical engineering, where my year and a half of computer science, you know what? It didn't even count anymore. It didn't count towards my major. I switched from 3 years to a 5-year plan. Now, my parents, they said okay, but they said, you know what, you're going to have to pay for your 5th year. And said, you know what, because this is something I really want to do, I'm going to do it. And in my sophomore year, I took BIM 1, which is the Introduction to Biomedical Engineering, and by complete chance, during that class, a TA said, hey, we have an EMT class here. Boom, opportunity arose. There's actually an emergency medical technician class here at Davis. I took it, one of the greatest experiences I've ever had in my life. I had a 10-hour observation there where I watched the head of neurosurgery at UC Davis Medical Center actually perform neurosurgery on a patient. And that was one of those experiences that changed my life, which would not have been available to me had it not been for the fact I switched into biomedical engineering. I was taking 18 to 22 units my whole sophomore year because I had to catch up. I was so behind. In fact, even though I was a sophomore, I was pretty much a freshman and standing in biomedical engineering because I had not started any of the classes. It was hard. It was challenging. But you know what? It was worth it because I loved every one of my classes. I'd be studying all week, but you know what? Because I enjoyed my classes, not only did I do well, I enjoyed it. So now junior year. I just received a paid internship at the UC Davis Medical Center working on a new technique for non-invasive traumatic brain injury. So this actually united my biomedical engineering background, my emergency medical technician background, and the CS background I had acquired in my first year and a half. So if anything, I didn't lose my computer science experience, I actually refined it. Refined it to a point where I could apply it to something I truly love. And so what does this all mean to you? Okay, I told you my story. You know what this means to you? It means to you that you need to seek what you love. You need to seek success, because opportunity will always be there. It will always be there if you're looking for it, if you're open to it. But the opportunity will only come if you're open to it because you enjoy what you're doing. Because of the fact I switched to biomedical engineering, I could become an EMT. Because I became an EMT, I could get this job at the UC Davis Medical Center, which not only do I enjoy it, it's something that leverages my experiences. And so, you know, that's what really college is about. The first 2 years is about discovering yourself, discovering what you love. And if you do that your first 2 years, I can guarantee you that piece of paper you get, that little piece of paper that you work countless hours for, you have numerous all-nighters for, and a paper that you spend a Sunday morning for, will be all worth it. Because you know what? That little piece of paper might just dictate something, a little something called the rest of your lives. And so that is the wonderful thing about college, is that sometimes the dreams you come in with may not be the dreams you leave with, but that's for the better. And so I thank you for your time. I hand you back now to Dr. Toupadakis. You guys are the Good luck on your midterms and whatever career you may pursue.
Okay. Ready to do some problems? Like the first, review session we had. We're going to go over some. And we can start. Which part will you start? 1, 2, or 3? You want to go like the ancient Athenians by screen? That's who is going to prevail. 1 or 2 or 3? Let me see your hand. 1, 2, 3. Interesting. You want the one, huh? The concept, huh? Okay. So let's start seeing a few problems from that section. So here is a problem that has to do with precipitation, right? And in this case, as we said during lecture, you will need to remember, or if you don't remember, you will need to use the rules about what salts are soluble and what are insoluble. Rule. Okay? So, whenever you see a tube, it means it's an aqueous solution of these pieces, right? These pieces are moving in water. So all these things are soluble things, as you can see. So when you put hydrochloric acid with an aqueous solution of ammonia together, you can see the base and the acid. We have seen that reaction will give you ammonium chloride, right? Ammonium chloride is a solid, but it's going to be in water, right? Because these two are aqueous solutions. So you ask yourself, ammonium chloride is a soluble or insoluble solid? So you know the rules. All nitrates or ammonium salts are soluble. So that will not give you a precipitate, right? You could actually write down, if you just want now, just for the sake of learning, right? You would write ammonium chloride, you would write it like this. Right? You will not write it like this. ammonium chloride, which is the product, is soluble in water. So it will be in the form of ion, not precipitate, so that's not the answer, right? Then you have potassium hydroxide and sodium chloride. You can imagine plus here, minus there, plus here, minus there. So the other combination you can have is this plus to go with a minus, and this plus to go without minus. Sodium hydroxide, strong base. Potassium chloride, all potassium and chloride salts are soluble. So nothing will happen, right? Correct? Basically what you will see is all these ions, like you can write it like this. This is the way you would write it, but that's not the answer because there's no precipitate. Okay, you can say the same thing here. Here it will form water, right? That's not a precipitate, salt precipitate. The only solution that remains is this one. And as you know, potassium nitrate is a soluble salt, so that's not the answer. But this too, silver chloride, is actually solid, which is not soluble in water. And so that's the answer, right? That's the way you do it. Everybody got it? Okay. Let's do the next one. As a strong electrolyte, sodium chloride will do what? Give all these different answers. So, a few seconds, let's vote, and then if anybody has a question why it is so, we can talk about it. So, let me see your hands. A, B, C, D, E, so most of, okay, anybody has a question why it's A? Okay, that's a pretty easy problem, right? If you have any questions at the end, we'll stay for a few minutes. And you can come at 8 to 10. I probably should make a pretty correct assumption that there might be people, or maybe more people, who knows, from the session of 8 to 10. If it is because it was too early, that's when many people show up. So I'll be here at 8 o'clock. If there's enough people, I'll make again a section like this. Otherwise, informally, I will answer a few questions, and then we can go home. So it depends how many people will come at 8 o'clock. You can come if you want, right, to hear more questions. All right, so the third one, we say the oxidation. So this is the definition of what is an oxidation, what is a reduction, right? Okay, so according to what you remember, what should be the answer? A, B, C, D, E. So most people got D, but how many people? I didn't see many hands though. So that's the correct one. That's a matter of definition. Really, we cannot say much about it, right? You have to remember that. Okay, this is an easy one probably. Yeah. Just again, just to remember this. What is expression that states the ideal gas law? Everybody should know this, right? How about 5? That's a good one. And it's a good one. Some people can answer really fast, but the interesting thing about this is that wherever you see it, from what nature remembers, all these years teaching and reading books, you hardly find anywhere to be explained. The way we can solve it really fast is not the science chemistry way. It is arithmetic way, a mathematical way, which has no any indication that we understand the laws of the gases. And so you might get it right, and that's what happens to many people. They get 4.0 or A+. They know how to answer questions, they get an A+, and then later they find out that they don't know anything. That happens many times. And some people with C or B, they can be very good students. The grades don't mean almost anything. Very little, they mean, very little. And sometimes mean nothing. Sometimes people are expelled by the university, and they are great minds and intellects like Steve Jobs or Einstein. And they will be kicked out by the so-called educational system of today's world. So, don't think that you are anything because you have good grades. You have gained something because you love and you understand what you're studying. You're not memorizing, you're understanding it. You find love in understanding it. That's true education. So we will solve it that way, just like that, right? Using an equation, but that means nothing. You get it right, but means nothing. Unless you can explain it to somebody, really truly understand what's going on. We're going to do it both ways. Okay? So, what do you think is the answer for number 5? A. All the way up. You are not your grades and you are not your answer. You are not your grades, you are not your answer. So lift up your hand and stop caring about the opinions of others. Otherwise you will never become truly successful. A.